One fire ranger at Station A reports smoke 30 kilometers away. Looks like words are missing here. Yes. I'm missing words, but you have all the words in your question, right? In a direction of east, 30 degrees north. So we've got Station A. Do you know how to do north, south, east, and west? Did you ever remember something? What did you remember?
Never eat soggy wieners.
Never eat soggy wieners. I don't know who ever came up with that, but it seems to be the one that people have heard. Okay, so if it's east, 30 degrees north, you would start at east and go 30 degrees towards the north. This is the direction of 30 kilometers where, here it is. We got the smoke. Okay. Oh, they didn't say anything about fire. They just see smoke, so I gotta move the fire away from it. Okay, they just see smoke. And then a Station C due east. So somewhere along this line is Station C, and it reports it to be 20 kilometers away. So let's say I put C here. It sees the same smoke at 20 kilometers. Is this the only possible place I could put C? Or could there be two triangles in this situation? There could be two. C could also possibly be, if you swung that around, it's possible that C could also have been here and had 20 kilometers. So this is our first example where there is two possibilities. You want to find the distance between A and C, and there's one possibility where it's the short distance and one possibility where it's the long distance. So we recognize this is the ambiguous case. And we'll talk a little bit about the homework questions in the textbook on how sometimes they have the ambiguous case and pretend it's not, or they're pretending to draw certain things to scale. So you might have looked at your answer and went, how did they get that answer? But we'll look at that after we're done this question. So this is the ambiguous case. So with the ambiguous case, my recommendation is to split your page in half and draw both triangles separately and solve them both separately. So one triangle is A here, C here, smoke up there. We know this is 30 degrees. We know this is 30 kilometers. We know this is 20 kilometers. I guess I'll call that B. And triangle 2, 30 kilometers still. This is still 20 kilometers. This is still 30 degrees. A, B, C. In one of the triangles, angle C will be acute. And in the other triangle, angle C will be obtuse. So notice in triangle 1, this angle is less than 90 degrees, but in triangle 2, now the angle C is bigger than 90 degrees. Sometimes the challenge can be just drawing them, okay? And that's part of the reason we did that activity to begin with, I find it's easiest to think about drawing them if you put the angle in the bottom left, the side you know right beside it, and then the opposite side that can swing around for two lengths. Then it'll be easy to see, oh, I could, if this was fixed pin here in this length of 20, I took my ruler and swung it around and I found out it hits again here, then you can draw both your triangles. But that is a challenge that is going to come when you do some practice questions. It's going to be a little bit of a challenge just drawing these pictures. So what do we want to find? We are wanting to find, the question is asking, to the nearest tenth of a kilometer, find the distance between both stations. So I'm going to just label that as little b because it's opposite of angle B. That's what we want to find. Can we use the sine law? Do we know three pieces of information? And do we know an angle and its opposite side? Yes. We know an angle and its opposite side, so these two go together. You want to find B, but do you know the angle opposite? So we don't know anything with B right now, so you would not be able to solve it. In fact, the only thing we could solve for to begin with is angle C, because that has an opposite with it. So what I would do is I would set up sine C over little c, which is 30, those two go together, equals sine of 30 over 20. Multiply both sides. And now I'm going to give you a mental math challenge without a calculator. Can you tell me what this fraction is in lowest terms? Did you get 3 over 4? How did I do that? This is one of your values from your special triangles. It's a half. A half times 30 would be 15. 15 divided by 20 reduces to 3 over 4. But this would be a calculator question because the next part you can't do without a calculator. We need to solve for angle C. Now, in grade 10 math, you would go right away to sine inverse. But since we're in grade 11, you have to think about your CAS rule and realize that if sine is positive, it could be in quadrant 1 or quadrant 2. So we need to first find our reference angle. And our reference angle for C will be sine inverse of the positive, which is already positive, 3 over 4. .59 degrees. What do they? We only want the nearest tenth at the very end. In fact, I'm going to go to my calculator here, and I'm going to show you that with your graphing calculator, so go second sine inverse of 3 divided by 4. That's my reference angle for C. I'm actually going to store that as alpha C. And my calculator is going to remember that it's C. So C is 48.59. That's going to be the answer in this triangle. Put it in green here, 48.59 degrees. But in this triangle, I would have to find the answer in quadrant 2. So if my reference angle is 48.59, my angle C could be this, or I could take 180 minus that reference angle and get 131.409, 0.41. And that will be the angle that's obtuse. Now, how did I figure out the 131.41? I used my cast rule and I thought if I have an angle in quadrant 2 and I know my reference angle was 48.59, does it make sense that to find this angle in standard position, I would have to do 180 minus 48.59. The other thing I want to show you, which I think is really cool, I drew both triangles separately, but on my original picture I had them drawn together. You see that this big one is the one on the left, and this small one is the one on the right. But when I draw them together, mathematically, I have another triangle here, where this is 20 and this is 20. What kind of triangle has two sides that are the same? Close. Equilateral has all three. Isosceles is the one that has exactly two. Technically, an equilateral triangle is an isosceles as well. But if you have an isosceles triangle, then this angle and this angle are the same. Well, we figured out this angle was 48.59, which would make this angle 48.59. And did you know that angles in a straight line add up to 180? So it's another way that you can figure out this one is going to be 131.41. It's kind of just neat to see that in perspective. So there's two ways that you can see that that angle has to be 131.41. One, using your cast rule and the trigonometry we've done already. The second is noticing the isosceles triangle. Yes. Or acute?
Yeah.
So acute means 0 degrees to 90 degrees. So just looking at that angle, it's less than 90. And obtuse means any angle from 90 degrees to 180 degrees. So I can see that this one is past the 90 degrees, making it bigger, making it obtuse. Now what's interesting is in our triangles up till now, we did solve for both things for sine, but usually when we labeled the bigger one, the triangle didn't add up. But in this situation, it's okay, right? Because 131 plus 30 is still less than 180 degrees. Okay. So, we still want to find little b. But the only thing I could find first was c. Once you have two angles, does it make sense that you can find the other angle? So we found c. Next, we can find angle b because you could take 180 degrees minus the 30 degrees minus the 48.54, and you will get angle b is equal to, and we'll solve this triangle first. So I'm going to go to my calculator. It was sure nice that minus 30 minus alpha c, it was sure nice that I saved it as c. Because now I can do this, and I get angle b. Sometimes you will lose marks for rounding early. If we would have rounded c just to 49 degrees, and then made b 101 degrees, our final answer might be off by a few decimal places. So this is now my angle b. I'm going to go and store that answer as alpha b. So my calculator is remembering what angle b is. I'm going to go to my triangle and label that angle of 101.41. We'll label that angle right there. We still haven't found what we wanted, which was side b. That's the last thing we need to find. But now we can use our sine law, because now with side B, I have the angle that's opposite it. So I can go to my sine law once again. We can find B, because B over, is it 101.41? Yes. B over sine of 101.4, maybe what I would show. Sometimes in my work, I would show a couple more decimal places with 3 dots. That tells the teacher, whoever's marking this, I haven't rounded. I'm keeping all of my decimal places all the way through. It's going to equal, and I need to use, I could either use the 30 kilometers and the 48.59, or I could use the 30 degrees and the 20 kilometers. Personally, in this situation, I would use the one that was given to me originally, because chances are it's not wrong. And so how do I get B by itself? I would multiply both sides by the sine of 101. And again, this is where it's nice to have this into my calculator. I can type, take out my fraction button, 20, sine, and instead of writing all of those decimal places, I can use the letter B. This is a strategy that comes up a fair bit. In 2 years' time, you're going to be writing, some of you are going to be in the AP Calculus class. We use this strategy on our graphing calculator of storing values as different letters, so we don't round early. Also makes it type, you can type a lot faster instead of having to type in all the decimal places. Divided by sine of 30, which is a half. Push enter, and you get 39.2. It says to round to the nearest tenth. That's one possible answer. Now we have to do the same thing on triangle number 2. So I'm going to scroll back up. On triangle number 2, angle C was the 131.41. I'm going to go back to my calculator. I'm going to do 180 minus C. That's my new angle C. And so I'm going to store this over top of the old angle C. So now I have an angle C as 131.41. Once I have that, can you see that you can find angle B will equal 180 minus the 30 degrees minus angle C? So I can go 180 minus the 30 degrees minus my new angle C, 18.59. I'm going to store that over top of angle B. So now I know this angle is 18.59 degrees. And again, I would use the 20 and the sine 30 because they were given to us. So B is going to be 20. Go back to my calculator, and I can go 20 times sine of that angle B divided by sine of 30. 12.8 rounded. I also like to, in these questions, as I'm solving for things, label them on my triangle as well. Just reminds me, what have I solved for already? What have I figured out? What do I have left to solve? Because sometimes, I mean, this was a word problem. More likely, I will give you just, not a situation, just a triangle. Sort of a question very similar to this one. I will tell you, and I'll say, solve the triangle completely. And if there's two triangles, you have to solve both of those triangles completely. And on your test, you're going to get one of those. On your next quiz, you're going to get one of those, where it's going to have two triangles, and you can solve it completely. Okay? Sometimes there is a hint. What kind of hint do you think a test or quiz has that this might be more work than just solving one triangle? How many marks it's out of? Right? It's probably not a huge question like this one. Like, oh my goodness, how much did we do? Lots and lots of work. If this was out of 1 mark, you'd be like, no, I don't have to do lots of work. But if it's out of like 4 or 5 marks, you're like, hey, wait a minute. There's a lot of marks here, and then my teacher is kind of giving me a hint. Maybe it's one of these where I have more than one triangle. Trying to figure that out. Okay? So I'd like you to circle 5, 6, 9, and 14. And I'm going to pull that up because, here we go. Five, 6, 9, and 14. Because I want to point out something that the textbook does. Starting with question number 5. So if you look at your question number 5, can you see that the angle here, the side opposite the angle, is less than the adjacent side, but the triangle has been turned, right? Again, you know, okay, I got confused where I am. Okay, it started like this. I should have labeled something. Oh, there we go. This was harder to do in my head than probably just redrawing it. But I want to redraw the 50 degrees there, the 9 here, and the 7 there. So it matches how we did things. How we did things is we had this line extend forever. Okay? And the reason I wanted to do this question with you is the following. If you solve this question, first of all, I want you to recognize that this is the ambiguous case. However, your textbook has the following policy. If they've drawn the triangle, they say they've drawn it somewhat to scale. If they've drawn this somewhat to scale, which of the two triangles is this? Is this the triangle where this is acute, or is this the triangle where that's obtuse? Does it look less than 90 or bigger than 90? look like it bends inward or bends outward? Bends outward, so that would make this obtuse. And almost everybody who does this question first on their own says, I got the answer wrong. Why did I get the answer wrong? Well, you got the answer wrong because you probably set up, okay, I want to find this angle here. I'll call it J, because that's what it is. And I'll go sine of J over 9 equals sine of 50 over 7. So I can get sine of J by itself. And if I do 9 sine 50 over 7 on my calculator, I get 0.985. Which is positive. So according to my cast rule, it could be in quadrant 1 or quadrant 2. The answer in quadrant 1 will be the same as your reference angle and will be acute. The answer in quadrant 2 will be obtuse. So what happens almost every single student on this question is they go second sine inverse of that answer, and they get 80 degrees, and they check the back of the book, and the back of the book has 100 degrees. Because your reference angle is 80 degrees, and this is obtuse, so it would equal 100 degrees. So just a warning in question 5, I think they have it for both of them. You have to look at this and determine from the picture whether it's obtuse or acute, which I think is a little unfair. On my tests, my triangles are never drawn to scale. On exams, they have a little disclaimer, not drawn to scale, so you would have to figure out both. This would be an example where you should figure out both answers. But the textbook assumes by the picture that it's bigger than 90 degrees. You almost have to turn your textbook sideways to see that.